Alright, ladies and gentlemen, today's video is going to be over lesson 7. We're talking about associated ratios and the value of a ratio. Alright, so we did most of this in class today, and we're just going to finish it up, provide students who are absent today an opportunity to see what we were doing in class today. So just follow along. If you are absent, then you've got the video to watch to help you out. We also have homework tonight. It will be informative. It's just going to be a couple questions. You can look at the questions. They're going to be the problem set questions. I'm going to upload them into formative later on today, so you'll have access to those. Alright, so first question. Which of the following correctly models that the number of red gumballs is 5 to 3 the number of white gumballs? So in other words, which of the following correctly models that the number of red gumballs is 5/3 the number of white gumballs? Now, what you need to remember is that fractions are identical to ratios. Okay, we just don't see them as such. Okay, we don't sit there and say a fraction is a ratio and a ratio is a fraction. We don't say that because we want to talk about the fact that ratios are a comparison of two different objects, where fractions are normally a part versus whole kind of scenario. But they tend to be identical. So if we're looking at a ratio of 5 to 3 in terms of red gumballs to white gumballs, the fraction is going to read 5/3, but the ratio is going to read 5 to 3, and it's going to be red gumballs to white gumballs. So we're looking for which option out of A, B, C, and D actually matches the ratio 5 to 3. So red's got to be more than white gumballs. So this one says it's 3 to 5. So A is not right. C is a ratio of 3 to 2. So C is not right. D is a ratio of 5 to 8. That's not going to be correct. So we're looking at red gumballs being 5, white gumballs being 3. So there's our ratio of 5 to 3. So B is going to be our correct answer. Okay. Moving on to example number 2. Okay. We've got the duration of two films are modeled below. Okay. Film A is going to be 1, 2, 3, 4, 5. Let's say 5 hours. Film B is going to be 1, 2, 3, 4, 5, 6, 7 hours. So film A is 5 hours, film B is 7 hours. So it asks us what is the ratio of the length of film A to the length of film B? Well, film A is 5 hours, film B is 7 hours. So our ratio is 5 to 7. Okay. Now, when we're trying to answer this question, the length of film A is blank of the length of film B. Okay. This we're looking for a fraction, and we're looking to write a fraction. Now, we write our fraction the same way that we would normally write our ratio. So if we write our ratio as a fraction, and we say the ratio of film A to the ratio of film B, we get a ratio of 5 to 3, and that is what the fraction is. The length of film A is going to be 5/3 of the length of film B. Okay, so that's our ratio. Now look at part C. It says the length of film B is blank of the length of film A. So again, we're looking at a ratio, but this time we're looking at the ratio of B to A. So the length of film B is going to be 7. The length of film A is going to be 5. So our ratio is going to be 7/5. Alright, so this is how we write our fractions when we know our ratios. Once you can identify a ratio, you can identify the fraction and write it in really quickly. And my butthead said, I'm sorry, I apologize. I said 5/3 here, and it actually should have been 5/7. I was still stuck on part A, so my apologies. I was looking at example 1 for some reason. I wrote 3 instead of 7. So part B is actually supposed to be 5/7. Okay. So let's go on to the next question. So our next question is going to be in exercise 1. Okay. I'm going to try to move things around here a little bit. Please don't get too sick on me. Alright, so we've got exercise 1. It says Sammy and Caden went fishing using live shrimp as bait. Sammy brought 8 more shrimp than Caden brought. When they combined their shrimp, they had 32 shrimp altogether. So how many shrimp did each boy bring? Alright, we have ourselves a situation where we have some information, but we don't have all of it. Okay, we know that Sammy brought 8 more shrimp than Caden, and when they combined their shrimp, they had 32 shrimp altogether. So this is where it would be beneficial for us to do a tape diagram. So we're going to write out a tape diagram here real quick, and we're going to say that this one here represents Sammy, and this one here represents Caden. Okay. Now, at the very beginning of this, Sammy and Caden had the exact same number of shrimp. But Sammy said, you know what, I don't think I'm going to have enough shrimp in order to do my fishing. So what I'm going to do is I'm going to sit there and I'm going to take 8 more shrimp. So Sammy brought 8 more shrimp with him. But we know at the very end their combined shrimp was 32. So altogether the total of Sammy plus Caden plus the extra 8 shrimp was going to be 32 shrimp. Okay. So Sammy plus Caden plus that 8 extra was 32. So what we can do is we can take 32 and subtract the 8 extra shrimp that we got from Sammy. So 32 minus 8 gives me 24 shrimp. So now we've taken care of that 8 extra shrimp that Sammy brought with him. But now, if you noticed, Sammy and Caden are going to be, well, if I could actually draw right, are equal to each other. So Sammy and Caden brought the same number of shrimp. So Sammy's amount plus Caden's amount is going to equal 24 shrimp. So we had 2 people that brought 24 shrimp with them. And they brought the same number of shrimp at that point. So all we got to do is take 24 and divide it by the number of people that brought shrimp, which was 2. So each person brought 12 shrimp. Okay. So Sammy in total brought 20 shrimp, and Caden brought 12 shrimp. Okay. So part B is asking us, what is the ratio of the number of shrimp Sammy brought to the number of shrimp Caden brought? Okay, so we're writing a ratio of the number of shrimp that Sammy brought to the number of shrimp Caden brought. Okay, so we're looking at a ratio. Sammy brought 20. Okay, Caden brought 12. So there's a ratio, 20 to 12. Now I ask you though, is that a simplified ratio? It's not. We can simplify that ratio. Okay, both 20 and 12 can be divided by 4. Okay, 20 divided by 4 is 5. 12 divided by 4 is 3. So there is our simplified ratio right there. 5 to 3 is what we're looking for. So let's look at questions C, D. I think I should be able to, yeah, I got D, E in there too. Okay, so we're looking at C, D, and E. So it says express the number of shrimp Sammy brought as a fraction of the number of shrimp Caden brought. Now, we're looking at trying to express the number of shrimp Sammy brought as a fraction of the number of shrimp Caden brought. Okay, now this is where we get fun at. When you're writing your ratio, you know that your ratio goes in a specific order. First number, second number. Okay, so in our situation in part B, we actually said that it was a Sammy to Caden ratio. Okay, so because we had Sammy first, when we write our fraction, all we have to do is take the ratio and rewrite it as a fraction. So it would be 5/3. So Sammy brought 5/3 as many shrimp as Caden. Okay, that's it. That is all we had to do. Okay, now if Sammy brought 5/3 as many shrimp as Caden, now it wants us to write a ratio of the number of shrimp Sammy brought to the total number of shrimp that were brought. Okay, now I could go 20-12 if I wanted to, but we know the total number of shrimp was 32. But we simplified that to a 5 to 8 ratio, or 5 to 3 ratio. So now this time, what we have to do is we have to think, okay, what's the whole? Alright, so what's the whole in this situation? We're not using 20 to 12. I'm sorry, whoops. We aren't using 20 to 12 because we simplified 20 to 12. Where in this situation, it would be 32 shrimp. In this case, we're using a 5 to 3 ratio, and to find our whole, remember, all we got to do is part plus part. So 5 plus 3 is 8. So that's our whole right there. Now Sammy's number was 5. Okay, sorry. Sammy's number was 5. Alright, so the ratio of the number of shrimp Sammy brought to the total number of shrimp is going to be 5/8. Alright, so Sammy brought 5/8 the total number of shrimp. Okay, so part E says what fraction of the total shrimp did Sammy bring? Okay, we know that he brought 5/8 the total. Okay, because that was our ratio. Our ratio was 5 to 8, my bad, and I wrote that as up here. Okay, I wrote this answer technically should have been down here, and the ratio was 5 to 8. Okay, but that was my bad. All right. Okay, so let's look at part 2. So exercise 2 here. Exercise 2. Okay, so a food company that produces peanut butter decides to try out a new version of its peanut butter that is extra crunchy. Using twice the number of peanut chunks as normal, the company hosts a sampling of its new product at grocery stores and finds that 5 out of every 9 customers preferred the new extra crunchy version. Okay, so I'm going to use some beads here real quick, okay? So we got 1, 2, 3, 4, and 5, okay? We got 5 people that like the new crunchy peanut butter, okay? And we've got 1, 2, 3, 4 people. There we go. So now we got 9 people here, okay? Alright. Well, I apologize, everybody. I know all that noise. Okay, so we've got 5 out of every 9 customers. Okay? 5 out of every 9 new customers likes the crunchy peanut butter. Okay? So what this is saying is that 5 people like the crunchy peanut butter, whereas 4 people like the smooth peanut butter. Okay? So these 5 here like the crunchy. These 4 here like the smooth. Okay? So 5 for crunchy, 4 for smooth. And I'm showing you this because we're going to sit here and we're going to do a little bit of manipulating to show you how each one of these fills in. Okay, so let's make a list of ratios that might be relevant for this situation. The ratio of the number preferring new extra crunchy to the total number surveyed. Okay, so we look at this. We had 5 people that liked the crunchy, 4 that liked the smooth. So how many people were surveyed? Okay, correct. There were 9 people surveyed. So there's our fraction. Okay, but now how many preferred the new extra crunchy? 1, 2, 3, 4, and 5. So 5 people like the new crunchy. Now we look at number 2. It says the ratio of the number preferring the regular crunchy to the total number surveyed. I said smooth, it's regular crunchy, my bad. Okay, so again we look and we see that we had 9 people that were surveyed. But how many people like the new or the old crunchy? 1, 2, 3, 4. So we had 4 out of 9. 4 out of 9 like the new crunchy, or the old crunchy. So we look at number 3. It says the ratio of the number preferring regular crunchy to the number preferring the new extra crunchy. Okay, so preferring the regular to the new. Well, we had 4 people that liked the regular, so there's our first part of our ratio. And then we had 5 people that preferred the new one. Okay, so 5 is our ratio there, 4 to 5. Okay, and the ratio of number of people preferring the new extra crunchy to the regular crunchy. Well, people that preferred the regular crunchy again were 4 people, so that's the bottom of our ratio. And we had 5 people that preferred the new one, so it's a 5 to 4 ratio. Okay, so now we can take these nice little beads we got and we can bring them down here a little bit because we're about to go to our next section. So we have, let's use the value of each ratio to make a multiplicative comparison for each of the ratios we described here. Now the number preferring new extra crunchy is blank of the total number surveyed. Okay, well, the number preferring the new extra crunchy, that was 1, 2, 3, 4, 5 people that preferred that. And the number of people surveyed were 5 plus 4, which is 9. So that's 5/9. The number preferring new extra crunchy is 5/9 of the total number surveyed. Alright, the number preferring regular crunchy. Okay, so this time we're looking at the regular. 1, 2, 3, 4 people preferred the regular crunchy. Out of the total number of people surveyed was 9. So 4/9 of the total surveyed. Now the number preferring regular crunchy is blank of those preferring the new extra crunchy. So we're looking at regular to new. Okay, the regular one was 4 people. Okay, the new was 5. So that's 4/5. The number preferring the new to the regular. Okay, well new was 5. okay, and the regular was 4. So 5/4 of the people. Okay. Now, if the company, now that's, we've done parts A and B, so now we got to do part C down here. Okay. So I'm going to come down. All right. So we can look at this. So if the company is planning to produce 90,000 containers of crunchy peanut butter, how many of these containers should be the new extra crunchy variety, and how many of these containers should be the regular crunchy peanut butter? Okay. So this is our question right here. This is what we're trying to find. What would be helpful in solving this problem, and does one of our comparison statements above help us? Okay, so we're going to go through these pieces, do these bit by bit. So we got 3 questions. We got question number 1, which is talking about the number. Got question number 2, that's asking us what would be helpful. Well, if I can spell it right, helpful. And question number 3 is asking us which of our comparisons, okay, would be helpful to this. Well, first off, let's ask what's going to be helpful. What would be helpful in solving this problem? Well, first we need to make sure we know how to multiply fractions. Okay, so we need to know how we need to know how to multiply. That's going to be helpful for us. Okay, we're going to need to know some other information. We're going to need to know. Let's see. We're going to need what would be helpful in solving this problem is multiplying. Using we need a fraction. Okay, we do need our fraction. All right, and that's where question number 3 comes in at. Which one of our comparisons? So if we got 90,000 containers, and we want to know how many are the number of new and how many of the number of old, we need to use a comparison measurement. So we're going to sit there and ask ourselves, which one of these 4 are going to be the best to help us? Well, I look at it and I see the 90,000, and I see it starts off with a 9. Okay, so I'm thinking to myself, maybe one of these 2 would be helpful because they both have a denominator of 9. So it might be helpful to help me simplify, because I know that if I have 5/9 are going to be the new, plus the 4/9 are going to be the old, then I can have a total of 100%, or just, 1. Because 5/9 plus 4/9 does equal 1. So I'm going to keep that in mind. I'm going to come back down here and I'm going to say to myself, okay, if I know 5/9 is going to be new, and I know 4/9 of the shipment is going to be old, can I figure out a way to use these to help me add them up to be equal to 90,000 containers? So that's what I'm thinking. I'm thinking to myself, is there a way that I can use these 2 fractions to help me out? Okay, that's what I'm asking myself. Can I use these 2 fractions? And I think to myself, yeah, they're comparison fractions. Okay, because if I can figure out what 5/9 of 90,000 is, that should tell me how many of the new crates I'm going to need. So I say, okay, so what's 90,000 times 5/9? Well, I need to rewrite this because I don't like this way this fraction is set up. So what I'm going to do is I'm going to rewrite it with a whole fraction line, and then I'm going to take the number 9, and instead of putting it underneath the 5, I'm going to come over here and put it underneath the 9, the 90,000, okay? Because now I can sit here and say, okay, hypothetically, put a little breakdown there like for me. Can I simplify 90,000 and 9? And the answer is yes. I can divide both 90,000 and 9 by 9. 9 divided by 9 is 1. 90,000 divided by 9, or 9 divided by 9 again, is just 1. So instead of 90,000, I have 10,000. So 10,000 times 5 is going to be 50,000. So 5/9 of the new containers is 50,000, okay, of the new. Well, that's interesting, because if you look at my comparison, it started with a 5 at the top. So if there's a 5 up here, and there's a 5 down here, maybe then the same thing can be said about, let me try to focus a little bit here, guys. There we go. So if this 5 and 50,000 match, then I should be able to say that the 4 and 40,000 should match, and that should be the old peanut butter. So 50,000 containers plus 40,000 containers does equal 90,000 containers. Okay, so 50,000 plus 40,000 does equal 90,000. I still maintain my comparison rates of 5 to 9 and 4 to 9. Okay, so everything checks. Alright, so that's one way of doing it. Okay. Okay, if you have questions about C, I understand. Come to me tomorrow and we will answer any questions. Okay, so let's take a look and continue on because we're almost done with the lesson. We're at parts D, E, and F now. Okay, so looking at D. If the company decides to produce 2,000 containers of regular crunchy peanut butter, how many containers of new extra crunchy peanut butter should it produce? So we're looking at 2,000 containers of regular. Okay. Alright, so it wants to know how many containers of extra peanut butter should it produce. Okay, so we go back and we take a look at our comparisons. Alright. Regular crunchy is 4/5 of those preferring new extra crunchy. So, if 2,000 regular, okay, is what we're looking at, then we know that 2,000 regular is going to be 4/5 of the original. Or sorry, not the original, the new. But we don't have the new amount to find out what 2,000 is. So instead we use our other comparison. We know that 2,000 multiplied by 5/4 will tell us how much of the new peanut butter we need. How do I know that? Okay, well, think about it. Alright, if I take 2,000 and multiply it by 4/5, okay, I'm not going to get a number bigger than 2,000 because you got to remember our ratio was a 5 to 4. For every 5 containers of new, we got 4 containers of old. So that means there should be always one more new container than there is old containers. So 2,000 times 4/5 is only going to be 1,600. 1,600 is not greater than 2,000, so we can't be using 4/5. We have to use the 5/4 because this is going to give us a number greater than 2,000. Okay? So 2,000 times 5 is going to be 10,000 over 4. 10,000 divided by 4 is going to be 2,500. So if they produce 2,000 regular, okay, they have to make 2,500 new to stay consistent with what they want in real life. Okay, so they're going to have to stay consistent by making sure those numbers match. Alright, so looking at E. If the company decides to produce 10,000 containers of new extra crunchy peanut butter, how many containers of regular crunchy peanut butter would it produce? Okay, so again, if our ratio is staying consistent, okay, for every 5 new containers, okay, we are getting 4 old containers. Okay, so there are now 10,000 new. Okay, now again, here we go, we got a problem. Okay, we're looking for the number of old. Okay, so we need to find out how many containers of old crunchy peanut butter that we're going to want to make. Well, that kind of comes back and that kind of comes back to a very interesting scenario, because if you look back at the beginning, when we used 4/5, we got a number that was less than 2,000. Okay, well, we need a number that's going to be less than 10,000. So instead of multiplying 10,000 by 5/4, we're going to multiply 10,000 by 4/5, because that will give us a number less than 10,000. So we're going to multiply it by 4/5. Okay. Now another way you could do this, if you wanted to, just saying, you can make a tape diagram. Okay. And it does work out this way too. You can divide it up into 5 sections: 1, 2, 3, 4, 5. Okay. And you know the whole thing is going to be 10,000, right? So each container is going to have 2,000 cases of the peanut butter. Okay. Now 4 out of every 5 have to be the old peanut butter. So here's 1, here's 2, here's 3, and here's 4. So 2,000 plus 2,000 plus 2,000 plus 2,000 is 8,000. So it's 8,000 old containers, or old peanut butter. So that's how many you would need. Okay, so you can see you can multiply 10,000 by 4/5, or we can make a tape diagram. Really doesn't matter. We'll still get the answer, and we'll show you on number F, because I think it'd be nice for you to see both of them. Okay, so if the company decides to only produce 3,000 containers of new extra crunchy peanut butter, how many containers of regular crunchy peanut butter would it produce? Okay, so we're looking at 3,000 containers of new extra crunchy peanut butter. And you remember our ratio, okay? It's a 5 to 4. For every 5 containers, okay, there's 4 old. Okay, 5 containers to 4 old. Okay, now I know what you're looking at. I know what you're thinking. You're like, wait a minute, why don't you do 5 here? Watch what happens, okay? So we got 3,000 containers of new extra crunchy peanut butter. Okay, so I'm going to make my tape diagram. Okay, and 5 containers. 1, 2, 3, 4, and 5. Now the whole thing equals 3,000. Okay, because that's how many containers of new extra crunchy peanut butter is. Okay, we want to know how many regular crunchy. Now normally, like I said, we were doing a 4/5. So we're looking at 4 out of 5 containers equaling regular crunchy. So we got to find out how many each of these containers measure. 3,000 divided by 5 is going to be 600. So each container, or each section, contains 600 jars of peanut butter. Okay. Now if 600 times 5 gives me 3,000, 600 times 4 is going to give me the old recipe. So 600 times 4 is 2,400. So 2,400 case containers, okay, is what's needed here. And now you're saying, but Mr. that makes no sense. That's the reason why I also want y'all to get used to the multiplying section, okay? If we take 3,000 and we know that we got to get fewer jars of regular crunchy peanut butter, we got to use the ratio that's going to be less than a whole. So we're going to multiply by 4/5. Okay? 3,000 times 4 is going to be 12,000. 12,000 divided by 5 is going to be 2,400. Same thing. Okay? Just be patient. I promise you, the more you do this, the more you practice, we're going to be okay. Alright? Now, what I want you to do for me tonight is I want you to make sure in your book, okay, you highlight this information here, okay? This is important for us, okay? This lesson summary is very important for us to understand what our lesson is about, okay? Just like these 2 problems in the problem set. These are going to be your homework tonight, okay? They're going to be informative. They're going to be titled Module 1, okay, Lesson 7. Homework. Okay? Alright guys. I will see you all tomorrow. Au revoir, arrivederci, ciao, hasta luego, Wiedersehen, das Vidania, peace and deuces.